Hello, good morning to everyone. Dear students, myself Gajanan Davande. Today we are going to take a video lecture, second video lecture of mathematics 9th class in CRT. First chapter is number system. Yesterday at the end, I have discussed about the Pythagoras theorem. So Pythagoras theorem is, again I am repeating that, there is a right angle triangle A, B, C. AC square is equal to AB square plus BC square. This is Pythagoras theorem. Clear? Is it okay? Pythagoras theorem. ये मैं इसलिए बता रहा हूं कि इसका इस्तेमाल होगा, ये आप आगे ट्रिग्नोमेट्री में डिटेल में पढ़ोगे, बट you have to remember this, that this must be a right angle triangle. Now, how they found out the value of under root 2? The under root 2, they have found out that the two sides of the square is of unit length, that is 1 and 1. If they join this, say this is O, A, B, C. So this OB length is equal to under root 2, which is irrational number. Yesterday we have discussed. OB is equal to under root 2. How we got it? That is here. AB, that is OA here. OA is equal to 1. AB is equal to 1. So we can find out OB square is equal to 1 square plus 1 square, which is equal to 2, and then OB will be equal to square root of 2. So this is the irrational number, and this length is equal to under root 2. Clear? So they got this length under root 2 from this square. Now we need to mark it on the number line, because every number, every rational and irrational number is available on the number line. So how we can mark under root 2 on the number line? This is our task. Clear? So we can mark this under root 2 on the number line. As usually, the number line is drawn like this. 0 is here. 1, 2, 3, 4. Okay. So this is, I will write, this is O, and this is the unit length. Say this is 1 centimeter. That is, point is, say, A. Here we will draw the perpendicular. Perpendicular, how we can draw the perpendicular? I will explain separately. Now, this is the point where you have to draw the perpendicular. You have to take the compass with some radii, draw a semicircle like this. You will get 2 points. Then more than radius, you must have marked this like this arc, and then join this point. So you will get this value. This angle is 90 degree. So like this, you can draw 90 degree here. Then measure 1 centimeter distance again by scale or by using divider. It is better to use divider. Nowadays the school boys are not using divider. They are using the compass, or directly they are measuring with the scale. So you can measure it with the scale. Say this is the point B. If you join this, you will get this OB is equal to under root 2. Means nothing else, as we have done in the previously, that 1 centimeter, 1 centimeter. So this is equal to under root 2 centimeter. So we have to mark it on the number line. So again, we will use compass. We will keep the center here and mark the arc like this. So this distance will be equal to under root 2. This is clear? So I can say that OC I can write. OC is the distance which is measuring under root 2. Now, definitely you will ask how we can measure under root 3, how we can measure under root 4, or how you can measure under root 5. Of course, under root 4 is equal to 2, so you can write down directly measure 2. But what about under root 3, under root 5, under root 7 and so on? So one by one we can draw it. So I will explain how to draw under root 3 now, or how to mark under root 3 on this. The procedure is same up to under root 2. Now this value is under root 2. We will extend this line. In the book this is not extend, but practically when you will draw you have to extend it. Then again draw perpendicular, as I have explained it earlier. Draw a perpendicular on it. Measure 1 centimeter, that is say D point. OD is equal to, BD is equal to 1 centimeter. OB is equal to under root 2. Join OD. OD is equal to under root 3. So now mathematically we can prove it also, under root 3. Now the triangle OBD, this one, OBD, this angle is 90 degree. Using Pythagoras theorem again, OD is equal to, OD square is equal to OB square plus BD square. How much is OB? That is here, that is under root 2 whole square plus, how much is BD? That is unit 1 square. So that is equal to 2 plus 1, which is equal to 3. So OD is equal to under root 3. Means the distance you are getting OD will be equal to under root 3. Similarly, now we have to mark it on the number line. So under root 3 again can be marked like this. We will keep the compass here, then mark the arc like this. So this is equal to under root 3. Now under root 4 again we can draw perpendicular on it. Procedure is again same. We have to extend it. This is 90 degree. Measure 1 centimeter distance. Join this. This will be equal to under root 4. Clear? So under root 4 will be equal to, it means under root 4 is equal to 2. So if you draw it like this, join on the, this will perfectly match on the 2. Now under root 5, so we will again draw perpendicular on it, 1 centimeter here, then again join it. So this you will, if you will, you would like to mark it on that, this is equal to under root 5. So you can draw so this length will be equal to under root 5. I think the meaning is clear now. To draw under root n, you have to make under root n minus 1 to find out the value of under root n, so that you can draw on the perpendicular on under root n minus 1, and then you will get the value of under root n. So that is the logic. Okay. So now we will shift to the next part. Exercise 1.2. The very first question is, that is of true and false. Every irrational number is real number. What is written here? Every irrational number, that is all the numbers are marked on the number line. We know that all the rational and irrational numbers are marked on the number line. So they all are real numbers. So the statement is true. Second one, every point on the number line is of the form of under root m, where m is a natural number. But in this case, all the positive values of the m are okay, but the negative values are not taken, and the under root of any negative number is not cannot be shown on the number line. So that's why this statement is false. Third one, every real number is an irrational number. Is this statement is correct? Every real number means all the numbers -1, -2, 1, 2, 3, 4, 5 and all the numbers, they are irrational. Now irrational means those numbers which cannot be written in the form of p by q, where q is not equal to 0. Okay, so they all are, the number line is including, or the real numbers are including all the plus and minus as well as 1, 2, 3, 4, 5 means all rational numbers and all irrational numbers. So this statement is also false. Now second question is, are the square roots of all positive integers is irrational, are the square roots of all positive integers is irrational? No, it is not true, because if you consider under root 4, so the square root of under root 4 is equal to 2, but 2 is a rational number. Similar example, you can take 16, you can take 25. Clear? So this is the example 2. So the statement you can write down. Now the third one, show how under root 5 can be represented on the number line. So for this we will use the previously we have solved it, but again I will explain. I will start it from the under root 4, that is under root n minus 1. What we have done, if we want to draw under root n, then we have to draw under root n minus 1. Here this is under root 5 we want to find out. So we will go for 5 minus 1, which is equal to 4. Sorry, under root 4, which is equal to 2. So first of all, I will mark it on the number line, that is 0, say 1, and this is 2. This is 1 and this is 2. What is the next step? On 2, I will draw a perpendicular by just marking the arc like this. Then marking the cut like this, and I will draw the perpendicular here. Then I will measure 1 centimeter distance here. This is say point O. This is point A. Then I will join this O B. So how much is this? This is 2. How much is this distance? This is equal to 1. So let us find out OB square is equal to OA square plus AB square. So OA is equal to 2 square plus 1 square, that is equal to 4 plus 1. So this is equal to 5. If I want to write down OB, then this will be square root of 5. Means this OB distance is equal to square root of 5. So I can mark it by keeping the center here and completing the arc with the help of the compass. So this distance is equal to under root 5. So you have to draw it very cleanly on the copy. So you can use this one. So now next heading is real numbers and decimal expansion. You know the decimal expansion also. In their previous classes, you have done it. For example, you have solved 1 by 2. So this is equal to, you know, that 0.5. Means after 0.5, the remainder becomes 0. So we have taken the 3 examples. Means here what we are doing, we are going to study the rational and irrational numbers in a different way. That is, in the form of decimals, we can understand by just visualizing it that the number is real number, rational number or irrational number. So now, first of all, we will expand this value, but in this case the remainder is playing a very important role here. So I will explain. 10 is divided by, or the divisor is 3, so 3 3s are 9. Here the remainder is 1. We will keep decimal here. Here is 0. Again 3 3s are 9. So again here this is 1 is remainder. So I can write here remainder is 1, remainder is 1, again 1, again 1, again 1, and so on. So again if I will write here, this is 3, 0, 9, again here this is 1. Divisor is 3. Clear? Now you can see here that here the remainder is same, constant, 1, 1, 1. And the values coming are like this, 3, 3, 3, 3.3333 and so on. Now, in the second case, we will see here 7, 8 is divisor, 0, 0, 0.8 is a 64. Here remainder is 6. So I will write here one by one so that you can understand very clearly. The first remainder is 6. Again I will keep it here 0. So 8 sevens are 56. So this is again 4. Okay. So now here this is 0. आठ सौ बत्तीस पंचालीस 8 5s are 40. So this is 0. Second time remainder is 4 and the third time remainder is 0. Here divisor is 8. So here you can see that the remainder is 0. Now in the third case 1 by 7. It's a very interesting thing. You will enjoy it. 7. Sorry. This is 1 and the 7 is divisor. Point 0 point. So 0 is here. 7. Remainder will be 3. I will write remainder here is equal to 3. First one. Then 0 here. 7 4s are 28. So the remainder is 2. The remainder is 2. Then 0, 7 2s are 14. So again remainder is 6. Remainder is 6. 0. 7 8s are 56. So this is 4. Remainder is 4. 0. 7 5s are 35. So again remainder is 5. Remainder is 5. Five is remainder. I am writing here. Now 0. 7 7s are 49. So the remainder is 1. 7 7, sorry, remainder is 1. Again 0. 7 1s are 7. 7 1s are 7. So remainder is 3. Means again this cycle is repeating. You will get 1, 4, 2, 8, 5, 7. Means the same remainder will be again repeated, that is 3, 2, 6, 4, 5, 1 and so on. So what you can conclude from these three, that is first case is 10 by 3, second case is 7 by 8, third case is 1 by 7. We have taken the three different cases. In the first case, what you can see that 3.33333. So the constant remainder is going on. Remainder is 1, 1, 1, 1. But it is non-ending. This is going on up to infinity. This will be 0.3, 0.3, 0.3, 0.3 up to infinity. Now, in the second case, remainder becomes 0 after certain period of time, or after certain calculation, or you can say after some string. Then this 0.875, the remainder becomes 0. Means this is terminating. This number or this rational number is terminating number, or this is terminating. But in the third case, not what you can see, that is 0.142857 again 142857 again it will come 14. So after certain period again the remainders are repetitive. It means this number and the first one and the third one, they are repetitive in nature. The remainders are repetitive in nature, and in the first case they are repetitive in nature from the first digit. Now in the case of third one, a certain string is repetitive in nature. Clear? Now what we can conclude, that first one, the remainder either becomes 0 after a certain stage. So this is the second case. After certain stage, the remainder becomes 0. So this is called terminating number. And these two are non-terminating numbers. Means this is repetitive. This is repetitive. This is also repetitive after a certain string. Means second, the number of entries in the repetitive string of remainder are less than the divisor. Means this number which is here, that is 3, 2, 6, 4, 5, 1, all the values are less than 7. There is no value more than 7 or equal to 7. Why? Because if the remainder will be 7, that means it will become 0. It will be completely divided. If it is 8, means you have done the wrong calculation. Because remainder will never be more than divisor. So this is, all these values are less, and this is repetitive in nature. So what we are getting? We are getting the three types of real numbers in which we are considering the rational, and we can divide it into rational and irrational numbers. So case 1, the remainder becomes 0, as we have discussed in the case of 7 by 8. After 5 means 0.875, the remainder becomes 0. So this is called terminating, means this is terminated at this point, remainder becomes 0. Now the remainder never becomes 0. Never becomes 0 means it is continue 10 by 3. We have taken example 0.33333 and so on. So this will be written as 0.3 bar. We can we read it like this: 3 bar. Here is only one number 333, that's why it is very simple to write down. You can say that is 0.33. But in the case of 1 by 7, this is repetitive after some value, that is after this string, that is 0.142857. So up to this value, again this is comes up. So this complete number will be under bar. So 0.142857 this will be repetitive, means this will be under bar 142857. Suppose now if some number is like this, that is 0.123123123 and so on. So you can write down 0.123 bar. For example, 0.45 bar means you can write down for 0.454545 like this. Clear? Okay. Now there is one example in your book. Show 3.142678 in rational numbers. You have to write down in the form of the rational numbers. Rational number means you have to write down it in the form of P by Q, where Q should not be equal to 0. These terms exist everywhere. If you are talking about the rational numbers, then this will be like this. Okay, P by Q. So I will say that this is 3.14268. Okay. So 1, 2, 3, 4, 5, 6. Again, see, you can see here what I am going to do. After decimal, I am counting 1, 2, 3, 4, 5, 6. So I will multiply it by 1 and 1, 2, 3, 4, 5, 6. Divided it by 1, 0, 0, 0, 0, 0, 0. Means if we multiply numerator and denominator by the same number, we will get the same answer. So that's why we are using that one. So 1, 0, 0, 0, 0, 0 and multiply, we will multiply it and divide it by this. So what we will get here, that is 3, 1, 4, 2, 6, 7, 8 divided by 1, 0, 0, 0, 0, 0. So now this is in terms of P by Q. Now you can see here that Q is not equal to 0. Clear? Q is not equal to 0. What is the value of P? That is 3142678. What is the value of Q? That is 1000000. So how we are we had rationalized this number just by multiplying the zeros. The 1000, that is after decimal. The digits are, there are 6 digits, so we are multiplying by 1000, that is 6 zeros are there in 1. That's with 1. So I think it is very clear to you how to rationalize this number in terms of P by Q. Now we have to rationalize. This is the simple case. Now we have to rationalize the number 0.333333 so on, means 3 bar. So you will think that how we can rationalize this infinite number, how we can show in the form of P by Q. So it is not very difficult, it's very easy. Now 0.3 bar we have to rationalize. 0.3 bar means this is equal to, we can say 0.3333 and so on. What we have to do? Very first thing, assume that x is equal to 0.333 and so on. Clear? Now I will multiply 10 on both the sides, that is 10x is equal to 10 multiplied by 0.333 and so on. So this value becomes 3.333 and so on. So 10x is equal to 3, we can write down like this also, 3.0.333 and so on. This point is very clear. 3.333 we can write down in by splitting it, 3 plus 0.333. Why? Because we know this, that is point x is equal to 0.3333 and so on. So what we will do? We will say that 3 plus, we will substitute this value x. Now transposing on this side, that is 10x minus x is equal to 3. So this is equal to 9x is equal to 3. So x is equal to 3 by 9. So we can write it down 1 by 3. This is equivalent rational and this is the rational. So x is equal to, this is the rational number is 1 by 3. And what is the value of x? Again the value of x is 0.333 and so on. So we can write 0.3 bar. So the rationalization of 0.3 bar is equal to 1 by 3 is the answer. Okay? Okay. Now rationalization of 1.27 bar. Here bar is on 2 and 7. It means this will be written like this, 1.27, 27, 27 and so on. This is repetitive in nature. Now here again what I will say, that x is equal to 1.272727 and so on. This is repetitive in nature. Okay. Here I will multiply it by 100 x is equal to 100 multiplied by 1.272727. Okay, definitely a question arises. In the previous problem I had multiplied here by 10. Here I have multiplied by 100. This is associated with this 2 digits. The number of digits which are repetitive in nature after certain calculations, it is 272727. That's why it is multiplied by 100. In the previous case this is 0.3333. So 3 bar is there, 0.3 bar means there is one number which is repetitive in nature. So 0.3 is multiplied by 100. So here in this case this is multiplied by 100 because there are 2 digits. So I am using 2 zeros after 1. So this is 100 multiplied by x. So this is 100x is equal to 100 multiplied by this value. So this is 1.27. So 12.72 7 2, okay, 12 point, so this is 120, 12.72 7 2 and so on. Clear? So now you just write down this is multiplied by, this is not 12.7, this is 100 multiplied by, so this is 127, sorry. So this is 127.27, 127.27, 27, 27 and so on. Okay. So we can write 126 plus, I can write 1.272727 and so on. Why? Because we need 1.272727. So that's why what we have to do, we have to deduct 1.27 from 127.272727. So we will get 126. So 126 plus, like this we can break. So this is equal to 126 plus x. So again, transposing it, 100x minus x is equal to 126. So 99x is equal to 126 upon 126. So x is equal to 126 upon 99. So this is in the form of P by Q, where Q is not equal to 0. Clear? So this is rationalized again. 1.272727 is rationalized in the form of 126 upon 99. This is the second example I have taken. Definitely you will say after some numbers, if the values are repetitive in nature, so I will take one more example which is also given in your book. So the third example I will take, that one is 2.0.235 repetitive, means 0.235 and so on. The things are same. Again I will say that x is equal to 0.235 and so on. Now here the next step is we will multiply it by 10 or 100 or 1000. So there are repetitive in nature, there are 2 digits. So we will multiply it by 100. Clear? So 100 multiplied by x is equal to 100 multiplied by 0.23535 and so on. This is repetitive in nature. So that is 23.3535. Clear? 23.35, 23.53, 23.5353. Clear? Again, what we need this value 2.35 after this one. So we can say that 0.23535 and so on. So 23.5353 minus 2.35 0.235, sorry, 0.23535. So this is 23.3. This is 23.3. Correct. 23.3. 23.3. Okay. So now this will be 23.3 plus 0.25 to 35, 35, 35 and so on. This is equal to 23.3 plus this value is x. This you can see here. So this is equal to 23.3 plus x is equal to 100x. So x is equal to 23 point, sorry, 100x minus x is equal to 23.3. So 99x is equal to 23.3. So x is equal to 23.3 upon 99. So x is equal to 233 upon 990. So this is again in the form of P by Q, where Q is not equal to 0. So like this we can rationalize the number. By doing the practice you can rationalize the numbers from the different books also, and so many examples exercise in the exercise the questions are given. Okay. From these three, what we can conclude that the decimal expansion of rational number is either terminating or non-terminating. Terminating means the remainder is 0, non-terminating means the remainder is not 0, but it is recurring. Recurring means 0.235, the values which are written under bar. If they are recurring and non-terminating, then that is a rational number. So, as we have discussed, started that the rational and irrational numbers are studied in a different way, means we can differentiate from this statement that if the number is terminating, it means it is a rational number. If it is non-terminating and recurring, means repetitive, non-terminating and repetitive in nature, then also it is a rational number. These are the numbers which are repetitive in nature but non-terminating. But the numbers which are non-terminating and non-repetitive, they are irrational numbers. Means the irrational numbers are the numbers which are non-terminating and non-repetitive. Means the remainder never becomes 0. It is non-repetitive in nature. Non-repetitive means the values are like this: 1.1532814261314 and so on. Means it is not repetitive in nature. The sequence is different up to infinity. Means you cannot get any value or repetitive in nature after a certain string also. So that's why this type of numbers are called irrational numbers. They cannot be written in the form of P by Q. The numbers which are repetitive and non-terminating and repetitive, or we can say recurring numbers, they can also be written in the form of P by Q, as we have solved this the examples like this. Now a very interesting thing, as we have discussed that under root 2, under root 3, under root 5, under root 6, under root 7, all these numbers are irrational numbers. Now one more thing, that is you have studied in the case of circle and that pi. Have you heard this one? Yes, this is mostly associated with the circle. So pi is having a peculiar type of number, and that is 3 point something. Any one of you are knowing it? 3.14 and so on up to infinity. Clear? So in the beginning, Archimedes, you know the name of scientist? It is a big mathematician also. He find the value of pi up to 5 digits. That is, I am not writing the exact one, but as I am remembering, 3.14085. At the beginning, Archimedes has mentioned that the value of pi is 3.14085. But later on, the Indian scientist or my big mathematician of India, that is Aryabhat, he has given the more closest value of the pi up to 4 digits, and that is 3.1416. This is given by Aryabhat, and this is more closer to this value. And later on, the research is going on, and the value of pi is calculated with the help of the supercomputers up to the trillions of the points, 3.14 up to the trillions value. So means it is the exact value. We are getting the very closest to the value of pi with the help of the supercomputers. Okay. Now we will start exercise 1.3. Keeping the basics, all the basics which I had explained. Now, our very first example is that is 1 by 7. We have to write down the irrational number in between 1 by 7 and 2 by 7. 1 by 7, as we have calculated, that 0.142857. Clear? And it is repetitive in nature. The bar, there is a bar on it. So that is value is, I will write here, 0.142857. Repetitive in nature. So I will write bar. And the 2.7, 2 by 7, that is, it will be 0.285714. So this is repetitive in nature. Now we have to write down the irrational number in between these two. Means it should not be repetitive. It should not be repetitive as well as it should not be terminating. It means it is 0.14. I will start, see here, that is 0.14 and this is 0.28. So 0.14 and 0.28. There are so many numbers we can find. There are infinite numbers as we have already discussed. That is 0.15 is there, 0.16 is there, 0.17 is there, 0.18 is there, 0.19 is there. Clear? So I can write 0.15, 0.15, 0.015, 0.015, 0.00015 and so on. Clear? Here we have to write down only one number, but you can write down so many numbers. That is 0.16, 0.1616, 0.01616, 16, 0.000, 161616, 0.016, 0.000 and so on. This is also number in between 1.15 and 0.28. Clear? So these are the digits which can be written, and but you have to write down like this. Means the number is extending up to the infinite. This number is not repetitive in nature, you can see, and it is not terminating also. So that's why this is irrational number, this is also irrational number. So many irrational numbers you can write down. Okay. So now exercise 1.3, this is the example which is given in your book. Now example 1, exercise 1, write the following in decimal form and say what kind of decimal expansion each has. What kind of decimal expansion means it is rational or irrational, that is terminating or non-terminating. So first one is 36 upon 100. So this is equal to 0.36. So this is terminating because remainder becomes 0 and it is not repetitive. Clear? That's why. Remainder is not 0, it means it is not repetitive. So this is terminating. Next, 1 by 11. So 1 by 11 point. So this is 0. It is still not divisible. So 0. So this is 0. So 9 ja. That is equal to 99. So here this will be again 1. So this will be 0, 0, 0. So 0. So 11 nines are 99. So this is equal to 1. So 0, 0. So this is equal to 0, 0, 99. So this is equal to 1. So non-terminating and repetitive or recurring in nature. Clear? Next one is 4 by 1 by 8. So this will be 4 multiplied by 8 plus 1 upon 8. So this is 33 upon 8. So again 33 is 8. 8 fours are 32. Remainder is 1. Decimal. This is 0. 8 ones are 8. So this is 2. Now this is 0. So 8 twos are 16. 8 twos are 16. So this is 4. Oops, 0. So 8 fives are 40. 0. So this is terminating and recurring in nature. Terminating, not recurring, sorry. It is terminating in nature, that is remainder is 0. It is not recurring. Clear? So the value is 4.125. Next one is 3 by 13. So I think that you can solve 3 by 13 I will take 2 by 11. So that is 2, 2 by 11. This is 11. Divisor is 2. 2. Divisor is 11. Sorry. 0 point. So this is decimal. 1s are 11. Remainder becomes 9. So this is 0. 11 8s are 88. So this becomes 2. 0. Okay. 11 8s are 88. So this is 2. Now 11 1s are 11. So this is remainder is 9. So again this is 8. So this is 88. So this is 2. It means we will get 1 8 1 8 and so on. So this is non-terminating and repetitive in nature. So it is a rational. So it is a rational number. Rational number is there because that's why we are finding out the nature. It is a rational number, so that's why we can find out this is repetitive or non-repetitive in nature. Next, this is the question number 1. 329 upon 400 that you can solve by your own. Next one is express in terms of P by Q, means rational in terms of rational numbers, that is 0.6 bar. Bar means it is repetitive in nature, so 0.6 bar can be written as 0.6666 and so on. So we can say that x is equal to 0.6666 and so on. Multiplying it by 10, as we have already studied that if the value is repetitive, the digit is single one, so we will multiply it by 10. So 10x is equal to 10 multiplied by 0.666 and so on. So that is equal to 6.666 and so on. So this is equal to 6 plus x. So 10x minus x is equal to 6. So this is equal to 9x is equal to 6. So x is equal to 6 upon 9. So we can write down that is 2 by 3. So x is equal to 2 by 3, that is in the form of P by Q, where Q is not equal to 0. Similarly, you can solve 0.47. 7 is bar. So you can solve this one. We will solve here 0.001. So there are 3 digits which are under bar. Okay. Zero point 0.001. This is under bar. So you can means it is repetitive in nature. So we can write 0.001, 001, 001 and so on. So x is equal to 001.001 and so on. What is the concept? That is 1, 2 and 3 digits are there. So we will multiply it by 1000. into x is equal to 1000 into 0.001001001 and so on. So that is equal to 1000 into x is equal to 123. So this is 1.001001001 and so on. So this can be written 1 plus 0.001001001 and so on. Clear? 1 plus 0.001001001. So this is equal to, again, 1 plus this term we can write down x. So that is equal to 1000 x minus x is equal to 1. So this is 999, x is equal to 1. So x is equal to 1 upon 999. This is in the form of P by Q, where Q is not equal to 0. Okay. Now, next one is again 0.999. So you can solve this one. P by Q. Okay. 8, 8.5 and 9 by 11. What is the question I will see in the book? Find 3 different irrational numbers between. Okay. Find 3 different irrational numbers between a 5 by 7 and 9 by 5 by 7 and 9 by 11. Between 5 by 7 and 9 by 11. So we will find out the decimal expansion of 5 by 7. So 5 divisor is 7. So I will see the remainder and then I will write down the value. 5 is the remainder here. In this case, 5. 5 is here. Okay. So 5, so 7, 7 ja. So this will be 0.714285. This will be 714285. Clear? If you will solve the problem number 3, you can understand very, very clearly, because in that you have to see how the remainder affects it. So now this is the value and the 9 by 11. So we can find out the 9 by 11, 0 point. So this is 0. So in the previous, I think I had done some mistake. So now you can see from here 11 point. So this is 0. So 11 9s are 11 8s are, sorry. 11 8s are 88. So this is 2 here. Now this is 0. 11 1s are 11. No. So this is 9 here. Again, this is 8 1, 8 1 and so on. So we have to find out in between 0.714285 and 0.818181. In short, we can say that we have to find out in between 71 and 0.81. So 0.72 will be the number, 0.73 will be the number, 0.74 will be the number, 0.7 and so on. So you can write number of digits in between that, but I will write few of them. So 0.72, 0072, 00072, 00072, and so on. 0.075200 A7895210001 and so on. Similarly, 0.8, 0.79, 0079, 00079, 00079 and so on. So you can write down the infinite irrational numbers in between the two irrational numbers, but you have to understand, first of all you have to consider the first two digits and then you can proceed further for that. So okay.